So we've been working for the last couple of days on solving some triangles using either the law of sines or the law of cosines. And all the ones we've done so far have just kind of resulted in one result. But there's one thing that we have not dealt with yet, and that was the SSA case, when you're given two sides and the not included angle. So we're going to look at this today. This is we call this the ambiguous case because depending on what you're given, some different things can happen. So before we take a look at this, let's do a real quick review of when we use the law of sines and when we use the law of cosines. So think to yourself for a second, what do we have to have given to us that we already know to use the law of sines? And you should be saying to yourself, either the AAS or the ASA case. In other words, if you're given any two angles and any one side, then that's when the law of sines comes through. You set up your ratios and you kind of go from there. How about the law of cosines? What do you have to have given to you in order for the law of cosines to apply? And again, you should be thinking to yourself that it's either the side case or the side angle side, two sides in the included angle. So we did those in class. At the end of this video, there'll be a couple of links. If you haven't seen those videos and want to see how to solve kind of those general cases for the law of sines, law of cosines, those links will be at the end of this video and down in the description. So again, we need to cover this last case when we have to when we see two sides in the not included angle. By the way, just real quick, what does it mean for it to be the non-included angle? Well, that's when the angle you're given, the two sides you have, one of them is opposite from the angle. So like for instance, you have angle A and side A, and then one of the other sides. So you have one adjacent, one opposite side. So let's jump in here and take a look at one of these examples, right? So the first one we're going to talk about here, by the way, I'm going to break this up into two sections. So this video here, we're going to talk about when the different situations happen in the ambiguous case, and then I'll stop this video, and then a second video, which will come shortly thereafter, which I'll also link to at the end of this one, will be specifically how to actually solve the problems, because that's when we'll actually get into the kind of nitty-gritty of the mathematics of it. But we're going to talk about when the situations happen to try to give you kind of a general idea of what you're going to be looking for. So let's say you're given this. So angle A is 30 degrees, side B is 9, and side A is 3. And if you kind of visualize that in your head for a second, we see that we got angle A, side A, so that's my opposite side is 3, and then my adjacent side is going to be 9. It's super important, and I stress this in class a lot, it's super important that we sketch the triangles kind of in a certain way. So if I'm going to draw this triangle, I'm going to draw it like this, where my angle is kind of down here on the left-hand side, so that's my 30-degree angle, and I call that A, or whatever it is, the angle that I'm given. And then I put my opposite side kind of where it's supposed to go. You see the 3 over there. And then my adjacent side kind of going up from the angle. And that way, it's kind of an easy visual to see what's going on there. Okay? Now, I've got a neat little illustration that I'll have to thank GeoGebra for. So here's our illustration on this thing, right? So we see that if we do that, that angle, that's 3 side right there, is kind of dangling. So it doesn't look like it reaches down to make a triangle. So let's think about that for a second. How could we, what do we have to do to make a triangle? So, because 3 obviously just doesn't reach right here. So what we're going to do is I'm going to go back to my smartboard file here. And we need to figure out what can we do with this thing. What is the minimum length that A would have to be in order for it to make a triangle? Well, let's take a look. If I manipulate this guy and I kind of make, because what's the shortest distance between 2 points? It's a straight line, right? So if I'm talking about this guy right here, the distance down to the bottom line would have to make a right angle. That's the shortest possible distance that it would be. So how could I find what that distance is, what that minimum length is to get down here? Well, this is my, if I just call this x, I can use a trig function to find what that length is, because I know that sine of 30, since it's the opposite and 9 now for this triangle, is the hypotenuse. So sine of 30 is equal to x over 9. So I can do 9 times sine 30 is equal to x, right? And now 30 degrees is a nice angle because we know that from our unit circle. So we know that's equal to 1/2. So 9 times 1/2 is equal to 4.5. So that's what x has to be, right? So if x equals 4.5, in other words, if my opposite side, A, is equal to 4.5, then I will actually have a right triangle. Okay? So let's take a look at that in our animation. By the way, it's important to notice if your opposite side, if my side A here is less than 4.5, it is not going to reach. So let's take a look at that on our animation again. So we have that, and notice here, if I start moving my A up a little bit, oops. So if I kind of see it's getting longer, it's almost there. If I get it right to 4.5, there is my right triangle. Okay, because again, that's the minimum length. So anything less than A, not going to work. But what happens now, so think to yourself for a second, what's going to happen if A keeps getting a little bit bigger? You know, if it goes up to 5 or 6 or something like that. Well, let's take a look. If it gets a little bigger, you see what happens. I'm going to bring it all the way up to 6 here. So let's say A was 6 instead of 3. Well, you can see now we actually have 2 different triangles possible. There's going to be one triangle at the point B2 where angle B is acute. And then we have a second triangle possible at the point B1 where B is actually obtuse. So we have that kind of great big triangle from A all the way to B2, then up to C. Then we have that little kind of skinny triangle from A to B1 all the way up to C. And notice, side B is not changing, side A is not changing, and angle A is not changing. Okay, but we do have 2 different triangles possible. That's why this is called the ambiguous case. Okay, now what happens, and again, just try to kind of visualize in your head for a second, what happens as A continues to get larger? What's going to happen if A becomes 9? Well, at 9, that's our old friend, the isosceles triangle, because these two sides would be equal now. And if it keeps on getting bigger than that, if we go all the way out to 10, let's say, then we still only have one triangle possible. Because obviously on the left-hand side way over here, there's nothing there, so that's not going to be a triangle. So we only have the one triangle made over there on the far right of B2. Okay, so to recap, if your opposite side that you're given is less than that minimum length, then there's no triangle that's possible. If A is greater than the minimum length but less than your adjacent side, that's when you have 2 triangles possible. Okay? And then when A is greater than or equal to the adjacent side, that's when there's just one triangle possible. Okay. Now, the good news when you're solving these things, and I'll get to that in another video, so this one doesn't run too long. The good news is we are going to use the law of sines for all of these things, regardless of what case it is, if it's one or two triangles. But we'll get to that in the next video. So I'm going to leave this screen up here for a few minutes and kind of wrap up this video at this time. So this kind of gives you a summary of the whole thing, right? We will use the law of sines for the ambiguous case. I would recommend whatever information you're given on the SSA, draw it like you see the figure on the left-hand side of the screen here. So put your given angle on the lower left-hand side, your adjacent side, and then your opposite side, and just kind of leave it dangling there until you're sure what situation you have. Okay, and then on the right, the bullet points you see there, opposite side less than the minimum, no triangles. Opposite side equal to the minimum, you got a right triangle. That's not going to happen very often. If the opposite side is greater than the minimum, but opposite from the adjacent, less than the adjacent, then there's two triangles possible. And then the last case, which we just saw, if the opposite is greater than the adjacent, then you have the one triangle. Again, all of those will be solved with the law of sines. So, and just to recap also, how do we find the minimum length of the opposite side? What is that minimum length going to be? It's always going to be the adjacent side times the sine of the given angle. Okay? So whatever the adjacent side is, multiply that by the sine of the given angle, and that will be your minimum length. And then that's the test you got to run first. And then from there you can determine if there's 0 or 2 triangles possible. Again, if the opposite side is greater than the adjacent, you don't need to run that test because you know there's one triangle. It's only if the opposite side is less than the adjacent side. So that's an overview of the ambiguous case. Again, in the description, there's going to be some links to the previous videos on just doing the general cases for law of sines and for the law of cosines. And then when I do the next video on the actual solving of these kind of examples, I will link to that one as well. Don't forget to subscribe if you want to see some more videos moving forward about all things pre-calculus and other interesting stuff once in a while. Thank you again for watching. Hope this helped you out, and we will see you next time. Have a great day.